Thank you so much, Michael. That was such a great intro. I am so excited to be here. Hello, everybody. So today I'm going to be talking about multisensory design or accessibility as a creative practice for designers. A little bit about our agenda. I'm going to start with an intro to multisensory design. I'm going to cover how we approach it at NYU. I'll define it for you, and then I'll talk about accessibility as a creative practice. After that, I'll go into two multisensory design case studies, which illustrate how incorporating different sensory modalities will increase access for our users. One project's going to be called Tactile Schematics, and the other is going to be a multisensory exhibition at the Intrepid Museum here in New York City. And then I'll wrap up with key takeaways for today's talk. I'm going to summarize key concepts for designers to consider in their own work. And I'm going to talk about the new NYU multisensory design class. But first, hello, hi, I'm Lauren Race, she, her. I'm currently Senior Principal Accessibility Designer at Oracle. Before that, I was Staff Accessibility Product Designer on the Twitter A11Y team. And then for the past 5 years, I've done accessibility design research at the NYU Ability Project. I'm also adjunct faculty there, where I teach a graduate level accessibility design class called Multisensory Design. So the Ability Project at NYU is a research space. It's dedicated to the intersection of disability and technology. And so the majority of our work is rooted in community engagement and co-design with local partners from the disability community. One of the main partners I've worked with over the last 5 years is the Andrew High School Braille and Talking Book Library. And I've learned so much about multisensory design through working with them. So I was first introduced to the Ability Project when I took 2 of their classes. So I took Developing Assistive Technologies, where students work with disability community members to DIY or do it yourself, their own assistive technologies, also known as ATs. And then I also took the Looking Forward class, which is a class on assistive technologies for blind and low vision individuals. We have a design and research lab for students. And so we have 3D printers, we have microcapsule fusers, we have digital embroidery machines, we have braille labelers, we have embossers. And so we have all these really great tools to support students in their multisensory design efforts. We also have a classroom. So the image on this slide shows a group of students presenting their final projects in the multisensory design class this past December. So a lot of the classes at the time that were coming out of the Ability Project were really focused on assistive technologies and community partnership, which resulted in a lot of really cool DIY work. So students would partner with members of the New York disability community to co-design DIY assistive technologies. Some of the projects coming out of the classes were we had an assistive wrist wearable for driving support. We had compression garments for lymphedema. We had a wearable to protect a partner from her cat's sharp claws on her lap. We had a relaxation tool for the NYU Dentistry School. We redesigned cribs for disabled goats with Goats of Anarchy. And we had an assistive toothbrush for dexterity and endurance support. So a lot of these projects were already incorporating multisensory design in them, but they were taking more of a problem solution approach, right? So I noticed that there was this opportunity to develop a new class that focused entirely on multisensory design as this creative practice. And I started to wonder, I was like, if you started by designing for the senses, would that create more accessible interfaces? And could it bring more joy and delight into people's lives? So I love this definition from the book, The Senses Design Beyond Vision. And so the authors here define multisensory design as extending the sensory richness of products, environments, and media. And they go on to say that by activating touch and sound and smell and taste and the wisdom of the body, you can support everyone's opportunity to receive information, to explore the world, and to experience joy, wonder, and social connections. Because the fact is our users have senses, right? Whether it's visual or auditory, tactile, olfactory or smell, or gustatory or taste, or proprioception, right? Which is the body awareness sense. It deals with coordination between the body and the senses, knowing where our body parts are and knowing how much force and strength to exert. And our users use their senses to perceive and interact in different ways. Some people interact best through sight, others through hearing, some through touch, maybe smell, taste, or proprioception. But since this is AxCon, a lot of us are really focused on digital accessibility. And when we think of digital A11Y, we're usually talking about sight, audio, and touch. We can't smell or taste the internet yet, like to my knowledge. If anyone can correct me, that is amazing. But for physical interfaces, I think smell and taste can be a really fun challenge for designers. WCAG does touch on proprioception, but mainly around like operability and regardless of input method. So for visual for digital A11Y, we think of captions, right? The image on this slide shows a person speaking with captions overlaid on their video. We think of screen magnification. We think of high contrast components and text. For audio, we think of audio description on our videos, right? We think of screen readers, so converting digital text and components to text-to-speech. The image on this slide shows a person listening to their screen reader. And then for touch, we think of refreshable braille displays, converting digital text and components again to dynamic braille. The image on this slide shows hands touching a refreshable braille display. So that's what we focus on the most for digital A11Y while we're aiming to conform with those WCAG requirements that are a part of our jobs. But as so many folks have said before me, WCAG is just the starting line. So my question is, okay, well then what's next? And I think that's where multisensory design really comes into play because it can help us look at accessibility through a creative lens once you've moved past that starting line. So we can get creative by focusing on all of the senses. So my design question is, in an ocular-centric world, how do we incorporate more multisensory ways of interacting with technology? And at the Ability Project, a lot of our work focuses on this design probe. So next, I'm going to share two Ability Project case studies with you to kind of ground this idea that multisensory design can be considered even if you're creating digital interfaces. So the first key takeaway for today is that multisensory design approaches accessibility through creativity, helping us design and innovate beyond WCAG conformance. WCAG has gaps, right? And when we find those gaps, it's just time to get creative. And so I'm going to give you an example to kind of bring this idea to life. So one way to practice multisensory design is to extend a digital interface through downloadable and printable tactile graphics. So this project was called Tactile Schematics. The platform was responsive web and tactile graphics as an SVG file. They were hosted on an NYU class website as an alternative to alt text. And so the main multisensory components for the project were touch, so for the downloadable tactile graphics, and then audio, which were the circuit descriptions that we offered through alt text. So the motivation for this work was that blind and low vision learners are underrepresented in STEM and maker culture, both of which are historically inaccessible. If you're new to the maker movement, it's a DIY culture of novice tinkerers of hardware. And so blind and low vision learners have limited access to STEM instructors who identify as blind or low vision and can teach in a non-visual way. So to increase access to making and STEM, we can offer access to information through touch. As our story goes, after about 40 years, NYU ITP, which is a grad program that we have, did not have learning material that was accessible to blind and low vision students. So in 2018, the program set out to make their curriculum more accessible to blind and low vision grad students. So the image on this slide shows hands exploring a tactile schematic of a continuity tester. So we had a website for the students to use for an intro course on electronics. The image on this slide shows an electronic schematic on the class site displayed on a mobile device. And some of the assignments used images of schematics. Schematics are drawings of the relationships between components in an electronic device. And students would use these to complete assignments to build circuits. And at the time, the images had alt text, right? But the circuit descriptions were so complex that they weren't enough on their own, especially for beginners. So I'm going to do a thing. I'm going to read out the alt text for the schematic on this slide so you can get a sense of its complexity, okay? All right, here we go. Schematic image of a 220 ohm resistor and an LED connected to a 7805 5-volt regulator. Regulator pins are numbered from left to right. One terminal of the resistor is connected to the regulator's output pin, pin 3, and the LED's anode is connected to the other terminal of the resistor. The LED's cathode is connected to the regulator's ground pin, pin 2. A 9 to 12 volt DC power source is connected to the regulator's voltage in pin 1 and ground pin 2. Woo! So there's a lot there, right? There's a lot going on. And like, who can understand that? Experts might be able to, folks that really understand this subject matter. But what about people who are beginners or people who learn best through touch, not through description? So it's really hard to understand a circuit from alt text alone, especially if you're a beginner with electronics. Electronics beginners can really benefit from the spatial information that schematics can provide, and they can learn the relationships of the components through touch, but only if those images are made tactile. And so this design problem really required creativity beyond WCAG conformance. And that's where tactile graphics can come in to help us, because touch can be incorporated in addition to image description through alt text. I'm obsessed with tactile graphics. They are an amazing, accessible education tool. They use raised surfaces to communicate information through touch. So you might think about it this way. If the conformance approach is to provide an image description via alt text for that circuit, then the creative approach is to reimagine that image through a completely new sensory modality, which in this case would be touch. The images on this slide show an SVG image of a schematic and then hands exploring a tactile version of that same schematic. All right, so how do we make tactile graphics? We use a special paper called microcapsule paper. It has alcohol in it. And when you add any form of carbon to that paper, whether it's printer ink or Sharpie ink or even pencil lead, and then you expose it to heat, all of those areas of carbon are going to puff up. We expose the paper to heat using what's called a fuser. I describe it as kind of like an easy bake oven. So you slide the paper through it and there's heating coils above, which make the carbon puff. It's a relatively scalable way for teachers to make tactile graphics, and we have a couple of them at the Ability Project. The images on this slide show paper being fed through the fuser and then a close-up of its dial set to medium. I do want to highlight that tactile graphics innovation continues. More recently, there have been 3 refreshable tactile displays in development. We have APH's Monarch, which is really new. We have Dot Incorporation's DotPad, and then we have Orbit Research's Graffiti. They're not in consumer markets just yet. And at the Andrew High School Braille and Talking Book Library, we identified 3 things that really need to happen before they can compete with tactile graphics. The first thing that needs to happen is that refreshable tactile displays need to be at least the same price as microcapsule or embossing, which would be about like under $4,000. The second thing that needs to happen is that the equipment, the training, and support needs to be easy to find. And then the third thing needs to happen is that the resolution, which is about 10 to 15 dots per inch, needs to approach the resolution of tactile graphics, which are about 100 dots per inch. But of course, like more tactile options are always a good thing, and everything is always changing. So how we imagine these graphics would work with the curriculum would be, let's say I'm a student. I open up the NYU class site on my phone to kind of navigate the electronics lab with my screen reader. I listen to a circuit description of how I should hook up the circuit. Maybe I try to trace the outline of the circuit spatial arrangement and I play it over and over and over again, but I don't understand it quite yet. I notice that there's a link underneath the image, which allows me to download an SVG of a tactile version of that same schematic image. So I print it on microcapsule paper. It puffs up when I run it through the fuser. And now I have this tactile version of that same image. So I can now feel the different electronics components like ground, and I can feel how they relate to each other. And so now I have this better mental model and understanding of how to hook up my circuit for my homework. And then lo and behold, I hook up my circuit, I press the button, and my circuit works for my homework. So we began making these, and we began with the schematics that were most critical to understanding the curriculum. And we did what we thought would work, which is to print the images out from the class website on microcapsule paper and run them through the fuser. The image on this slide shows a schematic of one of the first prints that we did, which is an analog in schematic. But of course, this really unexpected thing happened. The prints were completely unreadable, like so bad. We showed them to our design partners at the Andrew High School, and they were like, oh no, these need a complete redesign. These are terrible. So for the analog in schematic, for example, the schematic is way too tiny to be read by touch. And there's actually there's no braille labels, there's just text labels, right? Which are not going to feel like anything. They're just going to feel like clutter. Okay, so I will flag for motion sensitivities. There will be a GIF on the next slide of hands exploring one of these tactile schematics. So we co-designed with our partners at the library, and we kept improving with their feedback. The GIF on this slide shows hands exploring an early iteration of a tactile schematic. And through this whole process, I quickly learned an extremely valuable lesson, which is that designing for touch is not the same as designing for the eye. Just because you print out any image and make it tactile does not make it readable. In fact, tactile acuity is very different from visual acuity. Tactile acuity is about 100 to 200 pixels per inch, while from about 12 inches away, visual acuity is roughly 720 pixels per inch, though of course everybody is different. But really, you need to take time to thoughtfully design for touch. I went to art school and we were taught visual design. And I started to realize how underdeveloped my design skills were for other sensory modalities. And this is where I got really excited and I saw this whole new world of design open up. And this was really the beginning of my journey with multisensory design. So we were not doing too hot and we really needed to call in the experts from the library. So I will flag again that we're going to move on to another GIF on the next slide, similar with hands exploring a tactile schematic. So we further partnered with the Andrew High School Braille and Talking Book Library to make a system of all the individual symbols of electronics components. And we tested them over and over and over. And then once they were readable, we could use them like puzzle pieces, honestly, almost like a design system, really, right? Where you can put together endless schematic combinations of symbols. It took us a really long time to get the symbols in a place where they could be read easily through touch. And I remember thinking whoa, tactile design is a whole new and really critical design skill, especially for accessibility. The GIF on this slide shows hands exploring a tactile graphic of the tactile schematic symbol library. So with the Andrew High School, we went through 11 iterations to produce a tactile schematic that was discernible and usable. The images on this slide show the original image from the class website that we printed out as is. If you remember, that one did not work. Then we had the first version, which used a vertical layout and a braille labeling key. And then we had the 11th version, which used a horizontal layout to eliminate the key and tactile clutter. So I'm going to show you a following 30-second demo video, which shows the usability of the original file of the schematic from the class website. In the video, there's going to be close-up of hands exploring the tactile schematic before the redesign, while the participant describes what they're feeling as they go. This video does have open captions burned into it, so feel free to toggle off the auto captions right now if you'd prefer to do that.
The label at the top looks like some smudged, like LED resistor crossover. Then there's a line leading to text. There's definitely definitely a resistor leading to ground, but the lead is broken there. So the print didn't make it all the way through.
So there's some problems with the original file, like we discussed. As pictured here, it's way too small. If you remember that tactile acuity is 100 to 200 pixels per inch. There's text labels instead of braille labels. And the elements are way too close together. So it's just going to feel kind of like clutter or like a blob. And actually, some of the lines are gray, which means they don't have enough carbon in them to puff up in the fuser. And so you're going to lose those lines. So now I'm going to show a demo video with hands exploring the 11th iteration of the tactile schematic that was optimized for tactile discernibility. The participant again describes what they feel as they go. And this video will also have open captions, so if you prefer to toggle them off.
Here's a label up top, analog in, voltage in, it says plus V, and goes into a variable resistor, which is a resistor sign with a squiggle line through it. Then this line goes into, it says input to microcontroller, and it also continues down through a resistor and into ground.
Okay, so some fixes shown in this version was that we translated the text to braille. We included high color contrast ratio text that wasn't going to puff up in the fuser, which is great for folks with low vision. We optimized component symbol sizing with user feedback. And then we also included a slash in the upper right-hand corner so the reader knows how to orient the page, which follows tactile graphic design conventions. So now that we knew how to make these, we wanted to develop a style and workflow guide to support other designers who also wanted to make these. So we put together a set of design standards and best practices. So the first category is labeling. The image on this slide shows a page from the style guide of how to set the font size and the color for the tactile schematic braille and text labels. The second category was scale. So the image of this page from the style guide shows how to set the optimal height and width for each component of a tactile schematic. The third category was negative space. So the image of this page from the style guide shows how to put enough negative space between your components for tactile discernibility. And the reason for this is because when you put tactile elements too close together, closer than about a 1/4 inch, it feels like clutter and it's not clear what it is. And then the fourth category is contrast. So the image of this page from the style guide shows how to set the stroke weight for different types of schematic lines. So we had 2-point dotted leader lines for labeling. We had 2-point solid connection lines for component connections. And then we put an 8-point solid stroke around any microcontrollers to make them really easy and prominent to find. And then with our guidelines, we made 50 of these tactile schematics from the NYU curriculum. And they're now on the NYU ITP class website. Community sharing was a huge part of this project. So you can access actually all of the Tactile schematics and their guidelines right now for free. The website is tactileschematics.com. So when ITP students are learning schematics now, they can not only access a description through alt text, but they can also download a printable tactile graphic, which extends a digital interface with this tactile sensory modality. And the exciting thing was students started using these. We did a non-visual soldering workshop a few years back, and we used the tactile schematics to help blind and low vision students hook up a circuit that we were going to be soldering. So the image on this slide shows at a conference table, attendees sit at a soldering station with printed tactile schematics, while one attendee guides another's hand across their circuit board. So by the end of this workshop, we had 12 blind and low vision attendees soldering non-visually and learning through the tactile schematics. And we learned a lot from this project. The first thing is that flat digital interfaces are never a complete replacement for touch, smell, or sound. And I think when digital A11Y isn't enough, it's time for us to get creative, and multisensory design can really get us there because it inspires us to try other sensory modalities besides visual and audio. And this can really help us innovate beyond WCAG conformance. So the image on this slide shows hands exploring a tactile schematic of a continuity tester. And then the second key takeaway from today's talk is that interfaces with 3 or more sensory modalities increase access for our users. So a few years back, the Ability Project partnered with the Intrepid Museum in New York City, and we designed a multisensory exhibit and mobile guide. We used responsive web and exhibit kiosks for our platforms, and the multisensory components were touch, audio, proprioception, and then smell exhibit kiosks that supported content on the mobile guide. So the image on this slide shows someone using the mobile guide on their phone. So the Intrepid Museum is located aboard a World War II aircraft carrier that's docked on the Hudson at 46th Street. If you are ever in town, I highly recommend it. It is such a cool museum, and they have a fabulous access program. The image on this slide shows the large gray ship in the Hudson with the tails of some aircraft like just visible on the flight deck. So the Intrepid had some access issues during COVID when it really wasn't safe any longer to have in-person accessibility tours. And so they wanted to move a lot of their content online so people could access it from their personal mobile devices. And there were 2 main reasons for this, really. Is one, like some visitors felt more comfortable touching their own phones at the museum rather than like shared devices. And then the second is some visitors might feel safer at home using their mobile device from their couch. And the great thing about this approach is that they already had the accessibility settings of their choice selected on their device, making it more accessible and inclusive. So we worked with the Intrepid to design this mobile guide, and you could scan QR codes on signage to pull up corresponding pages with the guide. The image on this slide shows someone scanning a kiosk QR code with their mobile device. But like we talked about earlier, a flat interface can never replace interacting through touch or smell or sound, especially at a museum where it feels really exciting to be around historical stuff. And the Intrepid itself is a historical artifact. When you're aboard the ship, you can feel the chilly wind off the Hudson. You can smell the fuel. You can touch the cold metal walls. It's a very multi-sensory experience in itself. So when things eventually began to open up again, the Intrepid started developing an exhibit to celebrate other historical sites in the US, and they wanted it to be a multisensory experience as well. Some of the historical sites we worked with included, we had McCulloch Hall Historical Museum in New Jersey, we had Bainbridge Island Historical Museum in Washington State, and we worked with the Brandywine River Museum of Art in Pennsylvania. So the image on this slide shows an arched metal structure that houses several exhibit kiosks inside the Intrepid Museum ship. So I'll flag again that the next slide will have a GIF of a mobile screen scrolling upwards. So for the exhibit, we wanted to have both physical and digital ways of interacting with content. So we leveraged this mobile guide that we had built in partnership with the museum, and we expanded it to cover this exhibit in addition to the other ones that were already at the Intrepid. So the mobile guide offered accessibility features. We had maps with alt text. We had long descriptions that provided step-by-step non-visual directions to each exhibit. We had fast facts that summarized all of the page content in 3 to 4 easy-to-read bullet points. We had caption videos all under 10 minutes, photos with captions and alt text. And then we also had detailed visual descriptions of the entire exhibit written by the Access Initiatives manager at the Intrepid. And this was really cool because visual descriptions were typically reserved for accessibility tours, which were in person, but now we could bring them online and expand access to them. So now we had digital access to the kiosks in the exhibit as well. So this, the GIF on this slide shows a mobile device, which is scrolling down a mobile guide page. One of the kiosks focused on the olfactory sense. So smell is a really great sensory modality to bring historical sites to life. Like I said earlier, the Intrepid has a really distinctive fuel smell while you're aboard, which helps connect you to its history. So we wanted to do that for other historical sites as well, including Bainbridge Island Historical Museum. About 100 years before the museum even existed, the site was covered in strawberry fields. So we included something called a smell box, which invites visitors to open and close to kind of smell a rich strawberry scent. Being able to open and close it was really key for visitors with sensory sensitivities because it allowed them to control the experience for themselves. We also included tactile QR codes with traceable text that was tactile. So visitors using screen readers had tactile direction for where to point their phones. We use traceable text to include folks who didn't read Braille, but I do think in the future we want to include Braille labels as well. The image on this slide shows a close-up of the tactile QR code and a smell box on the kiosk. And then another kiosk focused on the proprioceptive sense. So one of the interpretations for the exhibit was a historical cast iron kettle from the Louisiana State Museum that was remarkably heavy. And the curator wanted to show just how heavy it was, even when it was empty, like not filled with water. So we allowed visitors to lift the handle using their proprioceptive sense. There were also buttons that would play a description of the kettle. And we also invited visitors to touch the cast iron texture through a hole in the acrylic. But the entire kettle was encased in an acrylic cube. So I think in the future, just engineering a way for the entire kettle to be touched could provide more tactile information. The image on this slide shows a kettle behind acrylic with just the handle exposed and then a small slot to reach in and touch the cast iron. And we had a tactile kiosk that used 3D printing to create a touchable replica. So this was a 19th century stove, also at the Louisiana State Museum. And the curator wanted to show the interpretation of the intricate molding of the cast iron. The stove itself was roped off to visitors and it wasn't allowed to be touched any longer. So we 3D scanned it and then we printed out this replica. We had exhibit space constraints, so we only scanned half of this symmetrical stove. This is something I think we'd want to change moving forward because we thought by having half of it, it's symmetrical, that's enough detail. But I think in the future, we want to show both the left and the right side of it because it gives a better overview of the shape and it gives more tactile information. The images on this slide show a 3D print of the stove and a visitor touching the intricate cast iron molding on the original stove. And we had another tactile kiosk focused primarily on tactile graphics. So we designed tactile graphics to interpret a painting of George Washington from McCulloch Hall Historical Museum. This painting was unique because typically portraits of George Washington showed him much younger and like leading troops. This particular painting was done later in life and it showed him as an older adult, which was very rare. So his face and his jaw were softer and less angular. So we had these two tactile graphics that compared his face shape when he was younger versus when he was older. And we learned a lot from this project too. The first thing is that you should have at least 3 sensory modalities present in your experiences. I think covering off on visual and auditory makes a lot of sense. Like I talked about, we live in an ocular-centric world, but we need to allow people to engage with their bodies in other ways, whether that's touch or proprioception or something else. And I think aiming for 3 or more is a good benchmark to meet. The second thing we learned is that you are not going to get it right on the first try, even if you think you did. So even the tea kettle, right? Like next time we'd want it out in the open so you could touch the entire shape of the kettle. We'd want to 3D print the entire shape of the cast iron stove. Our design is never done. So we keep iterating, we find good co-design partners, and we just keep making things better. And then the final thing we learned is that we had enough information on the mobile guide that visitors could have easily stayed home and learned everything that you'd learn on a tour from their couch. But even during COVID, people still came to the Intrepid to be in the presence of historical objects and to use their senses to feel more connected to history and how it felt to be aboard the ship. So again, it supports this idea from the tactile schematics work, which is that digital screens can never represent touch or smell or sound in the truest sense. Which brings us back to my original thought, which is in an ocular-centric world, we need to be thinking about multisensory ways of interacting with technology beyond just a flat screen. Because I think at the end of the day, the work that we're doing is because we're supporting people interacting and learning in their own way. Accessibility design is about options and meeting people where they are. And I think multisensory design really aligns with universal design for learning, which encourages multiple means of representation. So offering alternatives for both visual and auditory information, multiple means of action and expression, right? Allowing people to create and learn in ways that work best for them. But the main thing is our users have senses and we should be designing for those senses. So the 2 key takeaways from today are that multisensory design approaches accessibility through creativity. It helps us look at accessibility as a creative practice, helping us innovate beyond WCAG conformance. The second key takeaway is that 3 or more sensory modalities increase access for our users. Designers can consider incorporating at least 3 when they're creating experiences. In fact, University of California scholars, they had a paper called The Benefits of Multisensory Learning. They found that adult students who did multisensory learning needed about 60% less class sessions to achieve the same learning goals as students who did unisensory learning. So back to all these DIY assistive technologies coming out of the Ability Project. The multisensory design class started 2 years ago, and it's entirely dedicated to this work. It's really expanded how we approach accessible design at the Ability Project through focusing on the senses and accessibility as a creative practice. So I started the multisensory design class in the fall of 2022. So we've had 2 semesters so far, and we'll be back for fall 2024 as well. The class is very hands-on, and the students have 14 weeks to design and prototype one final project working in groups. And the only criterion is that their final project has to have 3 sensory modalities in both its input and output. They present to a panel of reviewers for the final class. Our reviewers come in from the local accessibility and disability communities in New York to offer guidance and feedback. We also have regular design crit where the students critique each other's work and try to get the project to the best possible version of itself. And so the projects coming out of the class are less assistive technology and more creative expression through the senses. So we've had an abstracted cat pillow that purred and vibrated when you pet it. It also smelled like cat shampoo. We had a gestural wearable for a disability-led operatic performance. We had an arcade game that dispensed jelly beans to taste and eat while also testing your cultural taste as well. We had an omakase interface that subverted taste expectations with touch and audio. We had a wristband that measures pulse and controlled sensory regulation compression on the body. And then we had an internet-powered back scratcher powered by a mobile app that the more people who pressed a button, the harder it would scratch the wearer's back. So a lot more creativity and expression than problem solution approach. And I remember one of the final project reviewers commented, she was like, oh, I unexpectedly had a lot of fun testing out these projects because we spent more time discussing the creativity and the sensory modalities than solving a specific problem. So I hope that these examples of multisensory design can help designers start to notice those gaps in WCAG and to use creativity to invite more people into the things that we're creating. I like to end with my favorite accessibility design quote that I use all the time. At Assets 2018, which is a conference, Carolyn McGrady said, "Stop trying to fix me, but do give me options." So thank you so much for having me today. Thank you so much to everyone who helped develop this work and the multisensory design class. That's Amy Hurst, Stephanie Kosef, Daniel Johnston, Tom Igo, Marianne Petit, both semesters of the multisensory design students. Thank you to Chancey Fleet and everyone at the Andrew High School Braille and Talking Book Library. Thank you to the inclusive design team at Oracle, the Intrepid Museum, and the Socially Distant Art Collective. You can find out more about the Ability Project if you go to ability.nyu.edu. And let's keep in touch, whether it's on LinkedIn or through my site, which is laurenrace.com. I am happy to support you in your multisensory design journey. Thank you so much.
Lauren, you ready to hear about how much excitement it's generated in the chat? A lot of people loved your comments, loved your engaging us in thinking about multisensory in some ways. And you've got one thing I'm going to tell the team is Lauren is going to get a document with all the chat messages in it and the questions that we don't get to ask today in our limited time. Lauren will see those as well, because I know, Lauren, before you went live, you and I had some conversations, and it's this dialogue that you've been having. And one thing that I got initially and throughout the whole entire presentation, Lauren, was how iterative it is, right? In the fact that you don't aim for perfection with the first iteration, you aim for some progress and learn from that, and build better and bigger things. And so I really appreciate the individuals who've attended this session, because just seeing your chats, like, you can see that message got loud and clear to everyone. So let's get into some questions for you real quick. There's some questions who are getting just incredible upvotes. And the first one I've got on my list is, how would you approach multi-sensory design in a fully online environment where in-person interaction isn't possible?
Can you tell me more about a fully in-person interaction?
So it's more of a, and I think some of the things you mentioned with the Intrepid, right, where you had the online application
Right.
that people could engage with.
Right.
I think what happens with our day and age, right, is online, you really are set with two senses, say it's hearing and sight. Have you experienced, or have you seen students go outside that and say, let's just not limit ourselves
Yeah.
to that online environment? And what are some of the other creative solutions you've seen with that?
Yeah, thank you for clarifying. Yeah, so I think that's why my students focus on physical interfaces. They're allowed to do digital interfaces, but I want them to start thinking about life outside the screen and what that might look like. Because again, once we put something behind a flat screen, there's not a lot of tactile information there. Like, it's literally behind glass. So I think, when I talked about earlier, we want to make sure we're doing all the best practices to make sure that refreshable braille displays and other screen readers can access the digital text on the screen. But I would love to encourage designers to also think beyond just digital as well.
Especially, I think, and Lauren, as we get into these virtual reality worlds and things like that, adding that additional sense in there, right, might even be something that's going to be more open to us, right? More available to us. So the excitement you generated today, one of the questions that immediately floated at the top is, Do you have any suggestions for resources if someone wants to learn more about multisensory design?
Yeah, start with Design Beyond Senses, the book. It was written, it was the Cooper Hewitt Museum. They did an exhibition a few years back and they prioritized multisensory in the exhibit itself. So I think that's a great place to start. I have tried to scour the internet and find all the multisensory resources. They feel few and far between, honestly. But one of my favorite examples that I show my students is somebody created a theremin with a cotton candy machine, and you would take the paper end of the cotton candy and run it in a circle. And as you're doing it and building up your cotton candy treat, you're also hearing a theremin performance and you're seeing visuals on a screen projected behind you. I know some students, some academic students also did gaming controllers that were ice cream cones. And as you would click the cone, it would activate interface. So I would start there. And if anyone finds anything that I have not found, please find me. If you go to ability.nyu.edu, you can find the multisensory design class site. And I have a resources page with all sorts of great things that I love to read, all the books I found. So if anyone can find more, I am all ears.
Oh, yeah. And the fact is that one of the things I think from the excitement generated, even from your talk today, right? These are things that we can help build. So the fact is, as we get ideas, putting them out there into the internet and allowing other people to see them and experience them, I think is going to just build that resource ever more. Because as we mentioned today, Lauren, you engaging us and saying, let's stop thinking about just the flat screen. Really encourages us to maybe go beyond what we normally would think of, right? So, so one of the person did mention the cool resources that you showed, like tactile graphics for students for one reason or other can't be physical present, or people that needed those game. Do those students? Would you having those students be able to take home those resources for studying as well? Um, and then the other thing, if you don't mind talking about that technology, how far off in the future do you see that some of that becoming mainstream technology? Because you mentioned that you had a couple companies who were providing some possible solutions. Could you talk about that as well?
Yeah, of course. So yes, they are more than welcome to take home the resources. That is what they are for. The paper is with inflation is getting very expensive, but that's why we have, budget and to make sure we have the resources that we need. Some students even had their either access to their own embosser or fuser. We also have the Andrew High School Braille and Talking Book Library locally, which is another great resource. The Ability Project, we have embossers, we have fusers. So there are many ways to access these things. It's about getting those digital files out there. Chancey Fleet, who I mentioned earlier, talks about image poverty. There are just so many images that have not been transcribed for touch.
Yeah.
That's the gap that we're trying to fill right now. And then Michael, remind me, what was the second part of the question?
It's just you talk about some of this technology that different places have. How mainstream do you see that becoming? I mean, I know cost is always going to be a consideration, but
Yeah.
it's available to more people kind of situation.
Yeah, I mean, as a tactile graphics obsessive, I would love to see this stuff become mainstream. I am a sighted person. I do learn through touch, and so I love access to tactile graphics, and I would love this to be more mainstream. I don't see a lot of folks, a lot of designers doing this type of work, and so a lot of what we're trying to teach our students is that there are these different ways to design, and so we're having students coming out of the Ability Project who can now design tactile graphics and are doing it in a career type environment, which is really great. So I think the more that we can get the word out about these really great resources, and also most importantly, that workflow guide, right? Because sometimes that cognitive load of a new workflow like this can be really overwhelming. And so the work that we did with Tactile Schematics is very work in progress. We always welcome feedback, but we tried to make it as simple as possible so that a designer who had never done these before can jump right in and go step by step through the workflow process. And then I think, again, like I talked about earlier, those three things need to happen. those three refreshable tactile displays are quite pricey because they are new and they're innovative, right? So that cost would need to come down for them to be more ubiquitous. You also need to have access to training and to the resources to use those materials. And then again, which I think is a significant one, that the resolution of those screens are just not approaching traditional tactile graphics yet. If we're comparing 10 to 15 dots per inch versus 100 dots per inch, that's a big difference. And so designing for a 10 dots per inch resolution is very different from designing for 100 dots per inch resolution. So then we need to think about this whole other world of tactile design. How do you design for 10 dots per inch? Very different. So yeah, we have a long way to go, but I'm very optimistic.
Yeah, and I like your first comment that you made about tactile graphics, because I think this multi-sensory idea, this conversation that you had with us today, we can't underscore enough, right? It's just not for people with disabilities. It's about inclusivity. So everyone has access to that learning. Everyone has access to that schematic, right? Kind of situation, regardless of your learning ability, right? Regardless of how you learn. Because Lauren, like yourself, to be a tactile learner, you just opened a new world for me, even if I don't have a disability and need braille or something like that to learn. So Lauren, I can't thank you enough. I know our attendees can't thank you enough for a fantastic session. I know you got a lot of us excited. I hope you got a lot out of the session. Now, I want to stop right before I sign off, and that is a couple of you asked about Lauren's slides. The team is still working on those. We'll get those uploaded. We want to make sure that they were completely accessible. Lauren had given it to DQ, and they're still working through to get those accessible. But I promise you will see those up online as well. And share this with your friends, because I think this is a really new way of thinking. And I think we can spread the word, as Lauren says, and bring more people on board about multisensory and how we can engage that. So thank you very much. Thank you, Lauren. Thank you for everybody who hanged out with us today. And hopefully you have a great rest of the day and continue to see you at AXCOM. Thanks.